In this video, we are going to look at, let me click my pen here, simplifying expressions with negative exponents. In our previous video, we looked at the basics of negative exponents, what they are, what they mean, and we learned that any number, call it a to the negative n power, simplified with positive exponents is actually 1 over a to the n power. So just keep that in mind. Negative exponent turns positive and gets moved into the denominator of our fraction. So let's look at our first example that we're going to look at here. 4x to the negative third, y to the fifth. So there's nothing to combine here, nothing to multiply together, no like terms or anything that I really need to combine. The only thing that I need to do is look at this x to the negative third and realize I need to write these with positive exponents only. So something needs to be done with that x to the negative third. And using the rule of negative exponents, it says that, okay, if I have x to the negative third, that means that this x to the negative third is going to move in the denominator of my fraction, and it will become positive. Now, the important thing to remember here, this 4 and this y to the fifth, nothing is happening with these terms. They have positive exponents. We don't do anything with those. So they stay put. So I'm going to keep my 4y to the fifth in my numerator, and this is going to be my simplified expression here. Okay, let's look at another example, number 2. Say we have 3a to the negative fourth times 4a to the second. Okay, the product rule, we got to go back a little bit to the product rule. So we're going to multiply the coefficients. 3 times 4 get multiplied like they are normal numbers. This is a multiplication problem. And then for my exponents, remember, the product rule says that I add exponents when I'm multiplying two terms of the same base. So I have a to the negative fourth, a to the second. That's going to give me a to the negative 2 power because I have added negative 4 plus 2. Now, I do not want a to the negative 2. I want positive exponents only. So remember, that negative 2 only applies to the a. So I am leaving the 12 in the numerator. I'm not moving the 12, but that a to the negative 2 power is going to become positive and get moved into the denominator of our fraction. Okay, let's look at one more for number 3. Let's go in parentheses 2a to the second power b raised to the power of negative 2. So the power of powers rule says that if I have an exponent outside parentheses, that exponent needs to be applied to everything inside the parentheses, the b term, the a term, and the coefficient of 2. So a couple ways you can think about this. Okay, I'm going to get rid of my arrows here just because that looks a little intense. There's a short way and a long way. So what I'm going to do is I'm going to think about, okay, I have an exponent of negative 2 right here. Doesn't a negative exponent just mean that whatever is being raised to the power of negative 2 gets put under 1? So here's what I can do here. I can say, okay, this is just going to be 1 over 2a squared b in parentheses to the positive 2. Right? I'm taking this entire quantity and raising it to the negative 2 power. So that means that that entire quantity gets put in the denominator fraction under 1. Now, I do still need to go ahead and simplify this using my power of powers rule. So that's going to give me 1 over 2 squared, a to the fourth, we multiply the exponents, b to the second power. You could leave that if you wanted to. You don't have to evaluate the exponents. I'm going to go ahead and evaluate 2 squared just because that's an easy one for me to evaluate. It's going to give me 4a to the fourth, b to the second. So my final simplified expression is 1 over 4a to the fourth, b to the second power.